So you want to compute a limit. How do you do it? Well, the answer, frankly, depends. So here I have a whole bunch of different examples, and let's just do each one of these, and I'll talk about what's different. So if you're given an algebraic one, like over on the left here, say this one here, if we have the limit as x approaches 2 of x squared plus 1, well, just plug it in. That's all you have to do. You just take the value 2 and plug it in for x. So that becomes x squared is 4, 2 squared, plus 1, so the answer is 5. It's that simple. A lot of limits are that simple. Please don't forget that essential first step. Otherwise, you might mess around trying to figure stuff out when it was just that simple. So the first thing is just plug it in. Now, let's take a look at the next one. My advice on the first one still holds. If we have the limit as x approaches 2 of x squared minus 4 over x minus 2, still plug it in first to see what you get. But in this case, we're going to get 0 divided by 0. Now, if you get 0 divided by 0, that means do more work. That's what that means. It means I have no idea at this point what the limit is. But in this case, we can do it fairly simply by factoring both top and bottom, because x squared minus 4 can't factors into x minus 2 times x plus 2 all over x minus 2. And those cancel. So really, we can just plug it into this x plus 2. So that's 4. So you plug it in, and then you do some more work if you have to. And you know you have to do more work if you get 0 divided by 0. That work is usually factoring. Sometimes it's multiplying by conjugate. It really depends. I could get into that. Leave me a comment if you'd like me to. But in this case, we just factored. And we got 4 when we just plug it in. All right, let's look at the next example. How about if it's given piecewise? Like this one. We have x squared if x is less than 2, but we have 2x if x is greater than or equal to 2. If it's given piecewise, you just check left and right. So just plug it in here, we get 4. We plug it in here, well, we get 4 again. Since they agree, the limit exists, and the answer is 4. If they didn't agree, the limit would not exist. So for a piecewise function, all you have to do is just plug it in left and right to determine if that function exists. Or sorry, if the left and right are the same. Okay, let's take a look at this last one here that's given algebraically. And it's another graphic one, right? Well, here's an example where just like I said a minute ago, let's plug it in. So for this one, we get 4, because if we plug it in 2 squared is 4. But we plug it in here, we get 3. Ah, that one does not exist. Just like I said a minute ago, if you plug it in and left and right are not the same, the limit does not exist. Now we're talking about just an overall limit. Left and right limits do exist, but that's a separate topic here. Okay, one final note is, what if we have a graph? Now, you'll notice that I actually listed the black, red, and green, those first ones here. These are just the graphs. So if you're given a graphic equation, I would do it very differently. Algebraically, you just plugged it in, right? Like this one, x squared plus 1, that's going to be the black line over here in the graph. So graphically, all you have to do is just say, okay, let's look in at x equals 2, go in left and right. The two arrows meet up, which means the limit is 4. If I look at the red graph, again, I go from left and right, back in following the graph to x equals 2. Since they point to each other, the limit does exist, and it's whatever that value is. Notice I don't care at all if the function value exists there. That would be, is it continuous? That would be that question. But just for a limit, I really don't care at all what's happening exactly at that limit point of 2. Don't care at all. And then just for completeness, looking at this last, the green one, well, we come in from the left, we come in from the right, they point to each other, so the limit does exist.